Grit blasting robots could be coming to a bridge near you. A small Sydney startup is in the process of commercialising the technology, hoping to tap into the $1.2 billion global abrasive blasting market. 2 prototypes are already hard at work on Sydney's iconic coat hanger. Inya Bjornsson has more.
Maintaining the Sydney Harbour Bridge costs $18 million a year, and in the underbelly of the arch structure is an important part of the maintenance team. Meet Sandy and Rosie, 2 grit-blasting robots stripping lead paint and corrosion.
It's very high velocity enough so that it can remove the paint and the lead from the surface. And also it would be able to cut through flesh, cut through metal if you left it onto the surface long enough.
They position it where they want, they press scan and it moves around and it builds a 3D map of what it wants. It understands the environment it's in, and then you press blast and it works out the most efficient way to blast that object.
The world-first technology was developed with funding from the Roads and Maritime Services and 6 years of research by the University of Technology, Sydney. Back in the lab, PhD students are working on the next step, enabling robots to talk to each other. The inventors are aligned with a successful blasting company and are already fielding sales queries from all over the world.
We've joined up with an investor who's also a distributor, along with Commercialising Australia, to give us 1 year to develop and commercialise our product.
The Grit Blaster is the university's most successful robotic graduate, but there are more than a dozen other projects on the drawing board.
It's still in the prototype stages.
Mark Armin Grimm is an undergraduate student developing a device that can help stroke victims with their physiotherapy.
If they're going down like that, they're not using the bicep. The control system doesn't engage the brake. If we want to engage the bicep, then if you're using it, it will engage the brake and apply a controlled resistance.
Ben Keat has a rare condition which left him a virtual quadriplegic. But despite his disability, there's no stopping this avid sports buff. The only problem in this game of adaptive cricket is fitting the bat.
Yeah, I need to angle a bit down, a bit more like smart. Yeah.
Now the university is batting for the team and working on ways to put more swing in the game.
What we are planning is to have a bat attached to this part and then extend it up to the front of the wheelchair, so the client sitting over here can have the proper view of the ball coming and also can have a better, stronger swing.
And the experiments don't end there.
If they nod the head, these sensors will detect that, and then that can actuate the batting system so that it can automatically hit the ball.
But all these ideas will take time to develop. Like Sandy and Rosie, making a name for yourself in robotics doesn't happen overnight.